All right, so we are going to talk about conic sections and then more specifically circles. So our goals for today are going to be what's a conic section, and then we're going to look at circles. We're going to look at deriving the equation for a circle, graphing a circle, and then writing the equation for a circle. So let's talk about, first of all, what is a conic section? And it's pretty much like it sounds. A conic section is a section of a cone. So if you take a look, we've got some slices here of different conic sections, and it depends on how you slice it. That's going to depend on what shape you get. So if you take a look, we got two cones that are stacked on top of each other, and if you slice it parallel to one of the sides of the cone, you get a parabola. If you slice the circle, or if you slice the cone perpendicular to the center axis of the cone, you get a circle. If you go at just a little bit of an angle, you get an ellipse. And then if you go parallel to the center axis of the cone, you get what's called a hyperbola. And notice the hyperbola is the only one that's actually going to get two parts to it. There's two branches to a hyperbola. And so depending on how you slice it, that's what you're going to get. If you want to have some fun, you can take a flashlight, and depending on how you aim the flashlight at a wall, you can get the different conic sections. Because if you think about the beam of a flashlight, it comes out in a cone. So if you beam the flashlight perpendicular to a wall, you're going to get a perfect circle. If you go at just a little bit of an angle, you're going to get an ellipse. And depending, this is going to be hard because you can't see the actual sides of the cone of the beam. But if you get it at the right angle, you get a parabola. And if you put the handle to the flashlight parallel to the wall, but still where it's making a little U shape, that shape's going to be a hyperbola. Conic sections are used all the time in optics and in acoustics. They're kind of the bread and butter of those two fields. So let's talk about a circle. Excuse me. Let's first of all derive the equation for a circle. These are super easy. So if we think of a circle, first of all, what's the definition of a circle? A circle is the set of all points equidistant from a fixed point. And that fixed point is called the center. So let's start with a really basic one. Let's start with a circle whose center is at the origin. So I will do my best to draw a circle. Let me just kind of mark some places on here to help me draw it. Okay, so all right, so here's a circle with its center at the origin. And if I just take a point, because I want to find an equation that's going to describe any point on the circle. So I'm just going to put a random point on this circle. It's got the coordinates x, y, because I don't have anything else to go on. But because of that definition of a circle, and we know about circles, we know that this actually represents the radius of the circle. And then if I go ahead and make one of those right triangles we've been making pretty much all year, we know that this side is x and this side is y, and we have a right triangle. We can use the Pythagorean theorem, and so we have x squared plus y squared equals r squared. And there you go. There's the equation for a circle. Not very exciting. If we were to translate the circle, so we move the we move the center off of the origin and put it somewhere else, then if we shift it by h and k units, h units left and right, k units up or down, we can come up with a more general form. And so, actually I should say standard form. So this is the standard form for a circle. First of all, we have this one. This is where the center is at the origin. But if I were to put the center somewhere else, so if I take it and shift it horizontally by h units and vertically by k units, then we get x minus h squared plus y minus k squared equals r squared. And now the center is moved to hk. And by the way, I want you to notice that we're used to x minus h. We're used to seeing that. And so we know it says x minus h, but if it said like x minus 3, h is going to be positive 3. But now we're also putting the k with the y. Normally the y is on one side of the equal sign and the k is on the other, but now we're putting them together. So the k is going to follow the same rule. If it says y minus 1, then k is going to be positive 1. On both of these, the radius is at r. All right, so let's just take a look at just graphing really quickly. It's not going to be that hard, and then we'll move on to the more exciting stuff. So graphing a circle. So what if I had a circle that was, let's say, x minus 3 squared plus y plus 2 squared equals 9. All right, so all you got to do is find the center and the radius, and once you know those things, then you have the circle. So that's your goal. Identify the center and the radius. So the center is, it looks like a negative 3 because it says x minus 3, but remember, change the sign, so it's going to be positive 3. It says y plus 2, so we're going to change the sign. Negative 2, there's your center. You don't have to do any work there. And then remember, r squared is 9, so that means r is 3. You always have to take the square root of what's there. So now we have the radius. Now we're ready to draw the circle. And I call them the north, south, east, west points. So if you, no, that's terrible. Let's see, we can do better than that. All right, so we got negative 3, or sorry, 3, negative 2. 1, 2, let me change colors. 1, 2, 3, negative 2. So there's the center. And then to help you draw the circle, just go up, down, left, and right, whatever the radius is, and then that gives you some points to shoot for. So up 3, down 3, right 3, left 3. And then just draw your best circle through there. And that's all there is to it. I always get lumpy on that corner. Oh well. So, there you go. There's drawing a circle. Not too bad. Let's try another one. What if we were going to graph x squared plus y squared plus 4x plus 6y minus 5 equals 0? Wait a minute. Something funky is here. Because, wait a minute, it's not in the right form. So we're going to have to change it to the form. So we're going to complete the square. It's like what we've done before. But this time we got two variables that are squared. The x is squared, and the y is squared. So we're going to actually complete the square twice. So it's going to be the exact same process that we've done before, though. So we're going to collect all of the terms, all of the x terms together, because we're going to complete the square and the x's. We're also going to get all the y terms together because we're going to complete the square and the y's. But everything else that doesn't have a variable, an x or a y, we're going to put on the other side of the equation. So that's going to be the first step. So we got x squared plus 4x, put those together, plus y squared plus 6y, put those together. And that negative 5, that's going to go on the other side. And now we complete the square. So with the x's, remember to complete the square, excuse me, it's always half of b squared. So half of 4 is 2, and 2 squared is 4. And notice how I'm putting them in parentheses now, because I'm completing the square, and it's going to help to kind of keep those separate. Okay, the y's, same thing. Take half of b and square it. So half of 6 is 3, and square it, you get 9. But don't forget, whatever you added to one side, you got to add to the other. If I added a 4 onto one side, I got to add a 4 onto the other. And then if I added a 9 on one side, I got to add a 9 on the other. So because of that 4 there, that's why I had to add that 4. And then because of that 9 there, that's why I had to add that 9. But now that we got that, Now it's going to be really easy to put it in the right form because now these are in the form of quadratics that are perfect squares. So x squared plus 4x plus 4, that can factor into x plus 2 squared. Remember, as long as you completed the square correctly, you always know take half of b, half of 4 is 2, and that tells you what to put in the parentheses. Half of 6 is 3, so it's going to be y plus 3 squared, and then you add all those numbers there, and you get 18. And now it's in the right form. Yay! So then we can go ahead and find the center and the radius. The center is going to be -2, -3, and the radius is the square root of 18, which is the square root of 9 times 2, because 9 is a perfect square, so it's going to be 3 root 2. There we go. I have all my information now. So now we can go ahead and do it. One thing that's going to be to note, in this case, it's actually probably easier to think of the radius in the square root of 18, because when it comes to graphing, I'm going to have to estimate how big the square root of 18 is. So remember, that's in between the square root of 25 and the square root of 16. The square root of 25 is 5, the square root of 16 is 4. 18 is closer to 4, so I'd put the square root of 18 somewhere between 4 and 5, closer to 4. That's all you need. It's good enough for the graph. So let's go ahead and graph it. I'm trying to plan ahead here. Let's scroll up just a little bit. -2, -3, there's my center, and then I'm going to go my north, south, east, west points. I'm going to go a little bit more than 4 up, down, left, and right. So a little bit more than 4, a little bit more than 4 down, a little bit more than 4 left, a little bit more than 4 right, and just draw your circle. Oops. And there you go. Oh, it's a crummy circle, but you get the idea. All right, so let's just do one more of those. I'm going to give you guys one to try that's kind of like this last one, and then we'll do it together. We'll just write it in the standard form. So we won't bother with graphing. So write in standard form. 2x squared plus 2y squared minus 12x plus 4y plus 3 equals 0. Find the center and the radius. So if you want to pause it here and try it on your own, go ahead. Just remember, this time I put a 2 as a coefficient in front of the x squared and the y squared. See if you can remember what to do with those. Okay, so if you want to pause it here, go ahead. And we're going to go ahead and solve it together. Okay, so again, I'm going to collect all the x's and the y's together and then put everything else without an x and y on the other side. So we got 2x squared minus 12x plus 2y squared plus 4y. We're going to put that 3 on the other side. So there's my first step. So my second step, just to save some writing steps, I'm going to go ahead and start leaving gaps for when I do the next step of completing the square. Remember, you can only complete the square when your coefficient of the squared term is 1, and right now it's 2. So I have to factor out the 2. I'm going to factor out the 2 from the x's, and I get that. Don't forget, I have to put them in parentheses now that I'm factoring. Factor out the 2 from the y terms, and I get that. And now I'm ready to complete the square. So complete the square on the x's. Half of -6 is -3. Square it, you get 9. So it looks like I added 9 on the left, but remember I really added 18 because the 2 times 9 is 18. So I have to add 18 here. So this 2 times 9 is what gives me 18. That's why I had to do that. Then if I go to the y terms, half of 2 is 1, 1 squared is 1. Looks like I added 1 on the left, but I really added a 2. So this 2 times 1 is what's giving me the 2. But now that I got through that hurdle, now it's very easy to finish it up. So I have 2 times x minus 3 squared plus 2 times y plus 1 squared, and then I get 17. And then the thing now is I can't have those 2's there. I have to actually get rid of them. So when you think of the form that I gave, the x minus h squared, there's no coefficient in front. So divide everything by 2, and that gets us x minus 3 squared plus y plus 1 squared equals 17 halves. Ta-da! And now I can easily identify my center and radius. So the center is at 3, -1, and my radius is at the square root of 17 halves. But remember, that's the same thing as the square root of 17 over the square root of 2. I can't simplify either one of those radicals, but I do want to rationalize the denominator. So I'm going to get the square root of 34 over 2. And there's my radius. And there we go. There's the center, and there's the radius. Okay, so we have derived the equation for a circle. We've looked at how to graph it. And now we're going to look at how to write the equation of the circle given some information. So I got 2 examples we're going to do here. You can be given a variety of information, but this will get the idea behind the 2 different things. So let's say that we were going to write the equation of a circle. Try to spell it right. With the endpoints of its diameter at 3, 2, and -1, 0. How are we going to do this? Well, if you want to think about it, you can pause the video now. I'm going to give you a hint, so if you want to get the hint and then think about it. Okay, so here's the hint. In order to write the equation of the circle, we need the center and the radius. So if you know where the diameter is, or a diameter I should say, could you find the center and the radius from that? So there's another hint, so if you want to pause the video and think about it. But let's go ahead and do it together right now. Alright, so let's just do a little quick sketch. I'm not going to precisely do it, but 3, 2 roughly here, -1, 0 roughly there. So we have the diameter of the circle right there. It's doing something like that. Well, if you think about it, we can find the center and the radius then pretty easily. The midpoint of the diameter is going to be the center. And then if we find the length of the diameter and just take half of it, we got the radius. So it's all about the distance formula and the midpoint formula. All right, so let's do the midpoint formula because that's the easier one. So let's find the center. And remember, the center is the midpoint of the diameter. All right, so midpoint formula is just the average of the x-coordinates, average of the y-coordinates. So the center is going to be x1 plus x2 over 2, and then y1 plus y2 over 2. Like I said, just the average of the coordinates. So we have 3 plus -1 over 2. There's my x-coordinates. And then 2 plus 0 over 2. Here's my y-coordinates. And on both of them, it looks like I'm going to get 1, 1. Which on my very quick sketch looks reasonable, so I'll go with that. So now we know where the center is. Here's the center. And that means we know what our h and k are. Remember our h and k, that's going to help us find part of the formula. Now we have to find the radius. which means we got to find the length of the diameter and take half of it. Now we could also, if you wanted to just do the distance from the center to either one of these points, that's also the radius, and that would be fine. I'm going to do the half the diameter because there's a point that I want to make, but either one is going to work, and I'd say either one is really just as easy, so it doesn't matter. All right, so let's find the length of the diameter. Now, the length of the diameter. So remember, the distance formula is x1 minus x2 squared plus y1 minus y2 squared, and it's all under a square root. Remember, it comes from the Pythagorean theorem. And you may be going, well, wait, I thought it was x2 minus x1 and y2 minus y1, and it doesn't matter as long as you're consistent, because it's all up to you which one is x1 and which one is x2. Okay, so the distance then, let me scroll this down so I can see my points. I've got 3 minus negative 1 squared, there's my x coordinates, and 2 minus 0 squared, there's my y coordinates. So then I'm going to have 4 squared plus 2 squared, all under the square root. So that's 16 plus 4, I get the square root of 20. Now it may be tempting to go, okay, so I take half of that. Half of that is going to be the square root of 10. No, do not do that. Bad. It won't work. And if you think about it, it also makes sense. The square root of 20, that's halfway between, well, not halfway, but it's in between the square root of 25, square root of 16. So it's in between 4 and 5. But the square root of 10 is between the square root of 9 and the square root of 4. Like, it's not going to work. Don't do it. So instead, you gotta divide by 2. The radius, I'll put it over here. So the radius is going to be the diameter over 2, half the diameter, which is the square root of 20 over 2. But this is one of the reasons why we simplify our radicals. A square root of 20 is the square root of 4 times 5, which means it's 2 root 5. Oh, the radius is really the square root of 5. So just remember that. Don't just take half of the radicand. You have to simplify your radical and take half of it. And if it doesn't simplify, it doesn't simplify. Like, let's just say that your diameter was the square root of 10, which doesn't simplify. Then your radius is just the square root of 10 over 2. And you leave it like that. You don't do anything. I'm going to get rid of that so not to do with this problem. And there we go. We now know everything that we need to know. So we're ready to go ahead and write the equation of the circle. Remember, we know HK is 1, 1. And we know r is the square root of 5. So, x minus h squared plus y minus k squared equals r squared. H was 1. K was 1. R is root 5, so you square it and you get just 5, and there is your equation of the circle. Ta-da! So there's one problem. Now let's just try one more, and then that'll be the end of this video. Okay. What if we want to write the equation of the circle? Tangent to y equals 4, y equals negative 8, and x equals 1, with a center in quadrant 4. Well, again, it's all about the center and the radius. If we can find the center and the radius, we can write the equation of the circle. Let's take a look at this. Will help if we draw a picture. So I got to go from negative 8 to 4. on the y-axis. That should give me enough room. Okay. Remember that these lines are horizontal and vertical lines. So the line y equals 4 is a horizontal line where all the points have a y-coordinate of 4. So it's this line right there. Y equals -8 is the equation of or is a horizontal line that goes through -8 on the y-axis. All the points have a y-coordinate of -8. X equals 1 is vertical, and it goes through the x-axis at 1. And that's all we got. But now we have an idea of the circle. Just very roughly, the circle's going to have to fit in somewhere like that. Now I can do a better job, find some more about this. But roughly that's where my circle's going to have to fit, because it said the center also had to be in quadrant 4. So I know it can't be on the other side of that vertical line. Well, this isn't so bad. All I have to do now is just find the diameter. Remember, the diameter will connect those two lines right there. So I know the diameter, the distance between -8 and 4, that's 12. So the diameter is 12, which means the radius is 6. And now I just have to go 6 units away from each of these lines. If I go over 6 units from that vertical line, so I'm going to go 1, 2, 3, 4, 5, 6. I'm going to have to be somewhere here. There's a very loose circle there, that highlighted one. And then halfway between 4 and -8, that's going to be 6 units. That's going to be right there. Right there is my center. So the coordinates for the center are at 7, -2. And we could also figure this out, if the numbers weren't as friendly. I know that, again, I can find the distance between two numbers by subtracting them. So if I subtracted 4 minus -8, that'd give me 12. So there's the diameter. And then I want to go down 6 units. So if I'm at 4 and I go down 6 units, just subtract, you get to -2. So that tells you your y-coordinate. And then starting at 1, if I want to go over 6 units, just add 6 and we get 7. So if the numbers weren't friendly, you could still do it with arithmetic and find that center. But now we know what the center is. And we're ready to write the equation of the circle. Yay. So again, x minus h squared plus y minus k squared equals r squared. Whoops. Ooh. And there's the equation. And there's circles in a nutshell. All right, have fun. Bye.